Hey folks, what's going on? Today we're going to be having a lot of fun. We're going to make some AR style filters using the face tracking that we set up last time. Today we're going to make this thug life example, which is pretty funny, as well as just using the landmarks and visualizing them on the face. Now, I would highly recommend you first start with last week's video because that covers how we actually set up the face track chop, how we built our face model.nvf file. And that's very important because without that, you can't do any of this. But with that set up, I'm going to go ahead and delete everything except my video device in here, which is capturing my face. Hello there. And the face track chop as we had it set up before. Let me go ahead and turn off all these extra buttons. So this is where we left off last time. We had the number of landmarks set to 68. And just to walk through that instancing setup really quickly, I'm going to create a select chop here. I only want to grab all of the point information. I don't need the bounding box for my instancing. So I can use the channel names parameter and type in star, PT, and then another star. And what that's going to do is basically only return to me the channels that have PT in them, which conveniently enough for us is all of our 68 landmark channels. And we can see that these are in UV pairs. So just like we did last time, I'm going to connect that to a shuffle chop. And I'm going to set the method to be sequence every nth channel. And I'm going to set that n value to 2 because we're basically telling it that all of our channels are in pairs. So we want to go UV and then go to the next sample and go UV again and then go to the next sample UV. So every 2 channels start a new sample. So that's great. Now we have our UV data ready for instancing. So I'll go ahead and make a sphere here. And I'm going to make this pretty small, actually. So maybe something along the lines of 0.1. We may even make it smaller as we go along, but that's small enough for now. I'm going to right-click on the output and quickly create a geometry comp. And on the instancing page, I'm going to turn on instancing. And then go ahead and first, actually, what I'll do is I'll make a null, because that's what good people do, is we're going to make nulls here. So I'll make a null after my shuffle chop. And then in my geometry, I can drag and drop that null to the default instance op. And then I can go ahead and assign my U and V coordinates. So now we can see we have all those spheres sitting where all the landmarks are on the face. Now, if you remember from last time, what I mentioned was if you need a reference to which point numbers relate to which positions on the face, one of the best things you could do is find this iBug resource. And if you need to quick refresher on how to do that, if you just do a quick web search for NVIDIA Maxine AR facial landmarks, usually in the top few hits is this AR SDK system guide in part of the NVIDIA Maxine documentation. You're going to go in here and right near the top, you're going to see facial point annotations, a little link here. And that's going to take you to the iBug page that has a nice little numbered diagram showing where every one of those 68 landmarks is on your face. So that's great because we're going to be referencing this a little bit shortly once we get to our thug life example. But for now, we have this kind of 3D instancing setup. And one of the things I think a lot of people are going to want to do is actually render this setup and have it overlay and fit on top of the original video camera input. So I'm going to start quickly by making a simple render setup. So I'll make a render top. I'm probably going to need a material for my geometry, so I'll use a constant map. And then I'll reference that on the render page of my geometry. And then the final thing is a camera that I need here. Now this is where the tricky part starts. And I think before we even talk about how to make the 3D coordinate space match our kind of real camera input, I'm going to first drop a select top so that I can just pull this camera feed and use it farther down in my network easily. Now I'll go ahead and composite these two with an over top. So I want my rendered content over my camera feed. And we can already see it's following the orientation, but is not quite lining up really all that well. Now there's a few things that we can do to make this very, very easy. The first is that we're going to want to go back to the face track chop, and we want to turn on the aspect correct UVs. And what this is going to do is take into account the aspect ratio of the original video texture and, you know, process the UVs behind the scenes to make it easier if we want to line our UV space up with our pixel space. So once we turn that on, we can see, you know, all of a sudden the aspect ratio is looking a lot better, because if I turn that off, you can see it makes my head look real scrunched up, and my watermelon head is not very scrunched up. Let's just put it that way. So I'll turn back on the aspect correct UVs. Now I need to actually change my camera into an orthographic camera. Now the reason we're doing that, remember, is all of this facial tracking is happening in a 2D space. Now next week we're going to dive into actually using the face track SOP as well to work with mesh geometry. But for today, we're kind of essentially living in 2D. So there really isn't any Z positions to these dots. And in that sense, we don't even need to use a perspective camera per se. So I'm going to go to my camera comp here, and I'm going to go over to the view page. And the first thing I'm going to do is change it from perspective to orthographic. The next thing I'm going to do is change the ortho width from 2 to be 1. And then the final thing I need to do is change this ortho origin from center to bottom left. It's a couple clicks of a button, and we've got these points and landmarks lined up pretty nicely. Now there's a few things we still might want to do with this. So firstly, I'm just going to make the spheres a little bit smaller here. That looks a lot better. We can see it's not bad, but you can see it's lagging behind a little bit. And this is what we were also talking about previously on last week's video, where there is a little bit of latency that we have to account for when using these GPU accelerated machine learning types of processes. So in that case, on my original camera input here, what I'm going to do is add a cache top right after it. And this cache top is going to be used to just delay our video signal by maybe 1, 2, or 3 frames. It'll really depend on what resolution camera you're feeding in, how strong your graphics card is, and a bunch of other factors. But usually once I find that I've kind of tuned it in for my system, it remains pretty well in sync. So I know that I'm only going to be doing maybe a maximum of 3 frames of delay. So I don't need a cache size of 32, because that's just going to be eating extra GPU memory for no reason. So I'll set my cache size to 3. Just hold 3 frames of data for me. And in this case, I'm working at 1280 by 720. I find 1280 by 720 is a good balance between getting that data in a really kind of high resolution, but also keeping it fast enough for the GPU to process as quickly as it can. Because as you add more and more resolution, you're essentially just slowing down the process more and more. So now that I have my 3 cache size here, I can zoom in to my over and start to just look at it and kind of eyeball it. So let's see what happens if I go to -1 on my output index. So that's going to give us a 1 frame delay, which is not bad, not too terrible. I'm going to go to -2. I think -2 is going to be our sweet spot today. And we can see -2 looks quite nice. Even if I move quickly back and forth, everything, all those spheres stay really tightly connected to the landmark on my face. So that's great. And we're going to keep doing a lot more content creation with face tracking, because we think it's going to be a really, really big feature that people are going to be able to use in their installations. Because look at all this rich data. Now you could go into 3D, start adding different elements, having them track those landmark positions, and have those render right on top of this scene. So already that's pretty cool. Now, one example that I thought would be fun to create would be that really classic old school YouTube thug life sunglasses, you know, the ones that fall from the ceiling. But in this case, we're going to have them tracking my eyes. So the first thing I'm going to do is actually bring in a little asset that I have here. Now, once I've got my asset loaded in here into the movie file, and we can see it's a little bit messy, and that's okay, because we're essentially going to crop out just the sunglasses so we can place them correctly on my face. So I'll go ahead and create a crop top. And I just want to make this as tight as possible. So I'll crop in a little bit on the left here, crop in a little bit on the right, crop most of the bottom out of here, and similarly crop most of the top out of here. Now, this is where we're gonna have to dive into some of the data that we're getting. And there's a lot of really great data. So if we go back to our face track chop, so far we've been using the landmarks and the aspect correct UVs. Now, in this case, one of the things that we're gonna account for right off the beginning is actually resizing our sunglasses so that they actually match the bounding box of the face. Because if you don't do this step, what's going to happen is you'll set them to be a good size when the face is maybe about this big on screen, but as people get closer or far away from the screen, the glasses aren't going to resize themselves dynamically to look like they actually fit that face. So there's a really easy way that we can do this. And I'm actually going to end up using a fit top for this. So I'll go ahead and make my fit top. And what we're going to do is dynamically update the resolution based on some of the information that the face track chop gives us. So what I'll do is use a select chop to pull out the channel that I want here. And what channel I want is actually the bounding box width. We can see face1/B box width. Now this is going to be a normalized value, so it's going to be between 0 and 1. And we actually want a pixel value because we want to know the resolution of this texture for the sunglasses. Now this is really easy, and if you haven't done this before, don't worry. There's going to be a few little maths that we're going to do here and there, but they're going to become second nature as you practice them a little bit. So in this case, we have a normalized value, and we want to bring it back to the range of 0 to 1280. So one of the really easy things we can do is on the math chop, go to the multi-add page, and just multiply this number by 1280. Once we do that, we're going to have the width of that bounding box in pixels as it relates to that same 1280 by 720p canvas that we're working with. So that's great. So now we know essentially the pixel width that our face is at any point in time. So I'm going to go ahead and put a null after this. And actually, I'm going to reference that on the resolution X here. Now, when it comes to the resolution Y, we could use a very similar process to calculate that. But what I find better in this case is because we know our width and we have a very specific aspect ratio that we want to keep our sunglasses at, we can actually just already use those two data points that we know to calculate the Y resolution of the sunglasses. So I know that here I have a 4.03 by 1 aspect ratio. So what I could do is type a very simple expression into the Y resolution here. So I could say me.par.resolutionW, which is essentially going to get the value inside of the X resolution. And then I'm going to divide it by that first number in the aspect ratio, so 4.03. So now you can see no matter how close or far away I get, as the X resolution changes, the Y resolution is basically going to update itself to keep that aspect ratio correct. Now we'll see this in action very, very soon. So what I'm going to do here is also just begin to set up my over composite. And we know we're going to composite our sunglasses over our image here. And by default, it's set to fill mode, which is not great for this. So we're going to go to the pre-fit overlay and change it to native resolution. And we can see as I get closer from the camera or farther away, those sunglasses are indeed getting bigger and smaller. And we're going to tweak this a little bit once we start having it follow the face a bit. Now, the fun part about all of this is it's not very hard to do. We're going to see, we're just going to grab a few data points of the landmarks, scale them a tiny bit, and then we're just going to apply them right onto the translate and rotation of the overtop. So we don't need to do anything fancy, no crazy extra geometry build, just grabbing data, doing a little bit of manipulation, and mapping it straight on here. So I'm going to go ahead and actually put this into the background so we can see it as we're working away. So now we need to find X and Y positions. Now, in this case, I would refer back to my landmarks here, and I can see, you know what, maybe something in the 28 to 29, because that's kind of where the bridge of the nose is. That's going to be the center of our sunglasses. I think that's a good place for us to pin it. So I'm actually going to use point number 29 here. So back inside of TouchDesigner, I'm going to create more select chops. I'm going to create one that's going to grab my X position of point 29 and one that's going to grab the Y position. So I'll connect both of those up. And then in the first one, I'm going to grab my channel names. I know I wanted point 29U. And for the second one, I wanted 0.29V. So now I have these UV positions for where they should go. So I'm going to go ahead and create some nulls at the end of the chain here. And there's a few things we have to do to process these. Now the X is really simple because the X is always going to be from 0 to 1. So you can see as I come all the way to the left edge of the screen, I'm getting closer and closer to 0. As I go all the way to the right side of the screen and shuffle my way over there, I get closer to 1. So that's really great. But we have to remember that by default, the over tops translate starts with 0 as the center. And it's actually going to be negative 0.5 as one edge and 0.5 at another edge. Now this is a very simple scaling that we can do here. So I'm going to insert a math chop after my 0.29U position here. And what I'm going to do is go to the range page. And here we're going from a normalized 0 to 1 to negative 0.5 and 0.5, which matches the left and right edge inside of our overtop. So with just that one math chop, we should be able to drag and drop that channel onto our X translate. And we can see now we got a pretty good X translation follow here already, just by one math chop and a select chop. So that's great. That's a lot of fun. So now we want to get the Y position so it follows up and down as well. Now this one is very similar, but there's one thing that we have to account for. And that is that we're using aspect correct UVs now. So what that means is that while my X position we can see goes all the way from 0 to 1, my Y position is not going to go fully from 0 to 1. So we can see if I go all the way to the bottom here, we're at, just about 0. And if I go up to the top of my screen, we're actually about just over 0.5. Now you might be wondering, what is this 0.5? Why doesn't it go all the way to 1? When we're using aspect correct UVs, what is going to happen behind the scenes is the UV range is actually going to shrink to match the aspect ratio of my texture. So in this case, I know that I have a 16:9 texture. So what I could do, very easy math here, is do 9 divided by 16, and that's going to give me the top end of my normalized range. So in this case, what I would do is instead of adding a math chop and scaling 0 to 1 to be negative 0.5 and 0.5, I'm going to scale from 0 to 0.5625, like we said, which is the result of this little calculation, which is taking your 16:9 aspect ratio, flipping the numbers around and dividing them together. And that's going to match to negative 0.5 and 0.5. Because remember, the output is the same. The output has to go to an overtop where the top and bottom are negative 0.5 and 0.5. So now that we've got that ready, we can also assign that channel. And now you can see I got a pretty good track in here on these sunglasses with just 2 math chops, 2 selects, and a face track. Easy, easy. But there's one more thing we're missing, and that's the fun rotation. You got to have the rotation with these AR style filters. So in this case, we need a rotation. Where are we going to get a rotation? Now we can go back to the face track chop, and lo and behold, there is a fantastic toggle button called rotations. So we're going to turn that on. That's going to give us an RX, RY, and RZ channel, which are going to be our rotations. In this case, we want to get the Z rotation. So same pattern and workflow as before. We're going to make a select chop, connect our face track chop to it. We're going to pull out our rotation Z axis here, and I'm going to put a null chop after that. So let's go ahead and assign this, and let's just see what happens. So I'm going to grab my RZ and throw it on the rotation. Now what we're going to see is it's rotating, but it's going the wrong way. So this is an easy problem to fix because what we can see is that it's going the wrong way in both directions equally. So that means we don't have to worry about doing any kind of weird scaling. We just have to flip our value range around. Also very easy with a math chop. I want to insert a math chop. And on the range, we have from 0 to 1. I'm going to set the 2 to be from 1 to 0. That's it. 4 math chops, a face track chop, and we've got a really nice looking AR filter that follows us pretty well. Now, the final thing you might want to do in this is like we said, right now the sunglasses are looking a little bit big for me, and that's because they're actually measuring out to be the full bounding box of my whole face. And unless you're wearing, Kanye sunglasses, the sunglasses are usually smaller than your whole face. So what we're going to do is go back to where we have our width here. That's where we take the B box width. We take it from the normalized values into our pixel space. And on the post add of our math chop, I can just say, you know what? After you have that width, take away maybe 50 pixels. So I'll say minus 50. And you can see now that the sunglasses get a little bit smaller and a little bit, maybe not 100% proportional, but a little bit better looking. And you can dial this in as you like. I could do minus 100, and all of a sudden they're going to fit inside of my face. But whatever you do, the process is really easy and flexible and can be applied to anything. So we're just using a very simple set of sunglasses. You can create different filters where you can have even circles or rectangles that are drawing on the face and processing those images. You can do so much with this that it's crazy, and it's crazy how easy it is. So this hopefully will give you a lot of really interesting things that you can play with. Stay tuned, because next week we're going to be diving into using the face track SOP to actually move into the geometry space of things. And we're going to be making a lot more fun content with face tracking. So for now, enjoy. Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.